Hello everyone, my name is Aruhi and welcome back to my channel. So guys, today's video is a part 3 of our travel planning system. So we have already done 2 videos on this project, and in my today's video we are just going to add new features in that project so that we can make it more smart and production ready. And these are the 3 features which we are adding today. We are going to add supervisor agent. Second feature will be guardrails, and third feature will be human in the loop. So these are the 3 features which we will add in our existing project. Now what will happen, user will ask a question. So user, let's say, asked plan a 4-day trip to Dubai for next month. Now on this user request we will run a guardrail. So guardrail will simply check if that request is valid, relevant, or if that request is safe. So if that request is safe, then only it will send that request to the supervisor agent. Otherwise, it will block that request. Okay, so this is the first feature. Now, supervisor agent will decide that what all agents are needed to process the user request. So over here, let's say user asked, okay, tell me the weather of Delhi. So these are the agents which we have. So out of these 5 agents, which agent will provide the weather detail? Obviously this weather agent. So on the basis of user's query, if user asks tell me the weather, then this supervisor agent will only pick weather agent because this particular agent is responsible to answer that question. Now if user asks plan a 4-day trip to Dubai for next month, now here user is asking to plan a trip, it is not asking for weather, right? So in this case, supervisor agent can select flight agent, hotel agent, budget agent, and itinerary agent. It can skip this weather agent. Why? Because user didn't ask anything about the weather. So what will supervisor agent will do? Supervisor agent will pick the right agents to answer the question. And how it will pick the right agents? It will see the user's query, and on the basis of user's query, it will pick the correct agents. And then we have these multiple agents. So flight agent, guys, these are the same agents which we have built in our last class. So flight agent is responsible to search the flights, airlines, fares, and timings. And for that, we used aviation stack MCP server in our last class. And then we have this hotel agent. Hotel agent is responsible for searching hotels, and we are doing it with the help of Teveli MCP server. Then we have weather agent. Weather agent is responsible to fetch the weather details, current weather, and weather forecast. And then this is the new agent, guys, budget agent. It was not in our previous project in part 2 and in part 1. We were not using this agent. So this is a new agent. We introduced it in this video only. So this budget agent will analyze the budget and it will estimate the cost, and then it will give the recommendations. And for that, we will use LLM. Which LLM we will use? Llama 3.3. Then we have itinerary agent. This agent we used in last class also, because the main goal of our project is to provide itinerary, to generate itinerary for user, right? So this is a travel planning system project. So we are using multiple agents, but the main goal of the entire project is to generate the itinerary for user. So for that, we will use this itinerary agent. And then we used a shared state, and the name of that shared state is travel states. This part I already discussed in my last class. So in short, it is simply a shared memory. All the nodes, all the agents will get the input from this state, and all the agents will update this state with their outputs. And then we are using the third feature, which is a human in the loop feature. Human in the loop simply means before generating the final itinerary, our AI system will show the draft of that itinerary. And if user approve that itinerary, then only our AI system will generate the final itinerary. And let's say human needs some changes in the itinerary, then human can write those changes, and then on the basis of that message our AI application will create the final itinerary, and for that we have another agent with the name of final response agent. This final response agent is responsible to generate the final itinerary, and we have this agent after human in the loop step. Okay, so human in the loop step, basically in this step we are just showing the draft of the itinerary. If user approve, then final response agent will create the itinerary, and if human requested some changes, then based on those requested changes, final response agent will create the itinerary. Okay, then for memory we are using PostgreSQL database only. So guys, please note that I will only explain that code which is new in our today's video. The coding part which we have covered in part 1 video and part 2 video, that I'm not going to explain you today. And guys, I have organized these videos in a playlist. So on my channel, I have created one playlist related to this travel planning AI agent project. See under playlist, see this Langgraph multi-agent system course, and click on this view full playlist and you will see these 3 lectures. See, the first one is part 1. So this is the very first video of this project. Please check this video. In this video I have explained each and everything in detail. Like, first of all, you need to set up the environment to run this project. How to create that environment, that part I have explained in this, and then all the coding part I have explained here. Then the second part is this, part 2. Okay, guys, before moving to the part 3, let me just give you a brief overview of what we have done till now. So, this is the workflow of our project in part 1 video. So, user will ask, plan a 4-day trip to Dubai for next month. Then we have these 4 agents. Flight agent is responsible to search flights. Hotel agent will search hotels. Itinerary agent will create the itinerary, day-wise itinerary, and final response agent was generating the itinerary. And in this project, we were using the APIs. See, this flight agent was using Aviation Stack API. Hotel agent was using Teveli Search API. Itinerary agent used this LLM, and final response agent used this LLM. Then we used a shared state, and then we used a PostgreSQL database. So this is what we have done in the first project. Then in second project, the part 2 video, we replaced the APIs with the MCP server. So earlier we were using Aviation Stack API, but in part 2 video, we replaced that API code with the Aviation Stack MCP server. So flight agent was using a local MCP server, and the local MCP server it used was Aviation Stack MCP server. Then hotel agent used Teveli MCP server, which was a remote MCP server. Then weather agent, it used a custom weather MCP server. So all these 3 servers I have explained in detail, how to create this custom MCP server, how to work with remote MCP server, how to work with local MCP server. So all this is explained in part 2 video. So that's why I've told you to check both the videos first. And then itinerary agent was using LLM. And again, we were using PostgreSQL for long-term memory and shared state, where all the agents were storing their output and they are getting input from here. Okay, so this is what we done in part 2. And let me show you the GitHub repo of these 2 projects. So this is the GitHub repo of part 1 project. And if you'll scroll down here, you will see how to create the environments. Then we activated that environment. Then we installed all the dependencies. And then I have shown how to download and install PostgreSQL database. And for that, you need to follow these steps. And then we created one database, this database. Then we created one .env file, and in that .env file, we need to store these variables. See, grok API key. Here you will write the grok API key. So how can you get the grok API key? So for that, you will visit this link and you can get the grok API key. And guys, all these API keys are free. And then Teveli API key, you will write over here. And in this variable, you will write your Aviation Stack API key. And in database URL, you will write the path of the database where you are going to store the users queries or the messages. So all these steps, how to perform them, I have explained in part 1 video. So go through that video and you will have your setup ready. Then let's open the GitHub repo of second project, the part 2 of our project. And this is the GitHub repo of that. And keep on scrolling. See, we are using the same APIs. So once you set up the environment from part 1 video, you don't need to again install modules in part 2. Okay. So just keep on scrolling. So what I'm going to show you over here. See, in part 2 video, we introduced the concept of MCP server. So you will perform the steps related to MCP server. Means if you want to work with local MCP server, we used Aviation Stack MCP server as a local MCP server. So for that, you need to follow these steps. And then after that, here I have explained you how to run this server. So then how to set up weather MCP server. So check part 2 video. You will see everything in detail, how each and every step is working. So after watching first 2 videos, your environment will be ready to run the part 3, which is our today's video. So now let's start part 3, and I am assuming that your environment is ready. So let's open VS Code. And guys, I have created a separate folder with the name of multi-agent system part 3, and we are going to write everything of our project in this folder today. Click here and name it agents.py. In this file, we are going to write the code related to all the agents. But before that, guys, see, here I have activated the environment which we created. And now in agents.py file, I'm going to write the code for all the agents. First thing is to import all the packages. First, we are importing this async IO module. Why we are using this module? Because we are working with MCP, and whenever you work with MCP, you need this module. So this module simply means till the time one request is getting handled or processed by the MCP server, our Python can perform some other work. And then we are using this JSON module. Why we need this JSON module? Because we are going to work with LLM, we are going to work with MCP servers, and mostly the output of LLMs or the output of MCP is in JSON format. So to handle that data, we need this JSON module. Then we are importing any from typing. So what this any means, any simply means, so suppose in our code, we are doing some task and we are using one variable or we are using a function which have different parameters. And if you don't know the data type of that variable or functions parameter, there we will use any. Then we are importing these 3 classes from LangChain core.messages. AI message class is responsible to handle the messages generated by the LLM. So whenever user asks a question, so that question goes to the LLM and LLM reply back. The message which we get from LLM, that message is handled by AI message class. And human message simply means this class is responsible to handle all the messages which user send. And system message class is used for system prompts. Then we are using this interrupt from langgraph.types. So guys, this feature we haven't used in our first 2 parts of the video of our project. So this is a new feature. Interrupt is used for human in the loop concept. When we use this interrupt, whenever langgraph wants the input from user, langgraph will stop the process. It will ask user to provide input. Once user provide the input, then on the basis of that input, langgraph will continue the process. So whenever you need the input from user, we need to stop the process of langgraph, the flow of the project. So over there, we will use this interrupt. Then we are using this get underscore LLM function from config. So guys, this config file we are going to create, we will create one file with the name of config.py, and in that file we will create one function with the name of get underscore LLM, and over there we will write the name of the LLM which we want to use. So in part 1 video and in part 2 video, what we did, we wrote everything in a single file, right? We were loading the environment variable in that file. We are loading the LLMs over there. We are writing the code for agents in the same file. Then we are creating the graph over there. We are running the code from there, right? So everything we wrote in a single file. But today we will organize our code properly. So we will create one file with the name of config, and we will write which LLM to use. We will load all the API keys over there. So those kinds of things we are going to write in config.py file. So let's create this file. So in the same folder, we will create this file. Click here and then name it and enter. Now we will write the code in config.py file first, and then we will go back to the agent.py and we will understand other things. So open config.py file. And this is what we need in config.py file. See, first we are importing the OS module. Why we need this OS module? Because we want to load the environment variables. So that's why we need this. Then we are using this load underscore .env. We need this module when we want to load the API keys from .env file. So first, let's create .env file, and in that .env file, we will save all the API keys. What all API keys we need? We need Teveli API key, we need Aviation Stack API key, we need Open Weather Map API key, and we need the database URL. So these 4 API keys we need to save in .env file. So let's create .env file. Click here and name it .env. Enter, and here paste the API keys. So these are my API keys. Now save this file and go back to config.py file. Then we are importing this chat grok class from LangChain grok. Why? Because today we are going to use the LLM from grok. So whenever you want to use grok with LangChain or LangGraph, you need this module, this class. So that's why we imported it. Then by writing this line, we are loading all the API keys. And then in these variables, I am storing those API keys. And after that, I created one function with the name of getLLM. Remember in agents.py file, this function getLLM. This function we are creating over here. And in this function, I have simply mentioned which LLM we want to load. So we want to load Llama 3.370 billion parameter model, versatile model. And using this model, our agent will perform the task. Now, let's suppose if you don't want to use this LLM and you want to work with some other LLM, then what you can do, just go to grok.com, see, open grok.com and click on the start building and just scroll down, and here you can see the list of LLMs. See, for reasoning, you can use these models. So different kind of models are here, and we are using this Llama 3.370 billion model. So you can pick any model as per your requirement from here. And after that, save this file. Now our config file is ready, and we loaded all the API keys and we loaded the LLM in this file. Now let's go back to agents.py file and let's see the next line. From MCP client, so you will create one more file with the name of mcp client.py, and in that file we have these functions. So in our last class, we created one Python file with the name of mcp client.py, and in that file we created all these tools, all these functions. See, current weather and forecast. These two tools are the tools of which MCP server? This weather MCP server. Then list airlines and list airports. Which MCP server is providing us the details related to flights? See, aviationstack.com. Aviation Stack MCP server we created. That MCP server is providing us the flight related details. So we wrote the code of these functions in mcp client.py file. And then we have Teveli search function. This function is responsible to perform the web search. So now let's create mcp client.py file. And guys, this is the exactly same file which we created in last class. So let's create the file and then we will paste the code from last class in this file. So create new file and name it mcp client.py, enter, and let's paste the code over here. See, this is the code in mcp clients.py file. First, we are importing this class. So I have told you in our last class that we need to import this module whenever we want to work with MCP client and MCP server in LangGraph. So that is what I've done. And then from this config file, the config file which we just created, from this config file, we are importing Aviation Stack API key, Open Weather API key, and Teveli API key. See, we have these API keys over here. So we are importing these API keys from config.py file in our mcp client.py file. Then in client variable, we are creating the mcp client and we are connecting it with all the servers, mcp servers. See, first we have a Teveli mcp server, and Teveli mcp server is a remote mcp server, and this is how you use it. Then we connected our client with the Aviation Stack mcp server, which is a local mcp server, and this is how you can run it. Then we have a weather MCP server, which is a custom local MCP server, and this is how you can use it. So this code is exactly the same. So I am not going to explain this part. So save this file and let's go back to agents.py file. Now we have this travel state. We are importing travel state from state. So guys, we will create one more Python file and we will name it state.py. And in that state.py file, we will create a travel state class. This part we have already covered in previous classes, part 1 and in part 2. But there are few modifications. So I will tell you about those modifications. So let's create state.py file. So click here and name it state.py, enter, and here we will paste the code related to travel state. So this is the code of travel state. First, we are importing these packages. So type type dict package. Why we need it? We need this package when we want to create a dictionary, but we only know the keys, we don't know the values. So what are Python dictionaries? We have key and we have one value for that key. So we use this type dict when we want to create special kind of dictionary. Means we have the keys, we know the data type of the values, the kind of values which we are going to store for that key. We know that, but we don't know the exact value. When you want to create that kind of dictionary, then we use this type dict. See this travel state class. So we created one class, and in this class we want to store data in the form of type dict dictionary. That means key and their data types, not the actual values. See, user ID is a key, and then we mention the data type of the value. Means the value which we are going to store for this key will be string. Then there is another key, user query, and the data type of the value which we are going to store in user key will be this. In the same way, these are the different keys and every key have a data type, and this data type tells what kind of value we are going to store in it. And then we are using this operator module. See, we are using this operator module over here. I'll tell you in a minute why we are using it. Then we are using this any message from langchain code.messages. Any message also I'll explain you in a minute. So we have this class. In the first line, see, messages is a key. In this key, we want to store data like this. Now let's understand this. So first thing is any message, the module which we are importing over here. Any message simply means that when user will use this application, whether user send a message or it is a reply from a AI or it is a system prompt, all the messages we want to store in a list. We have a list. In this list, we are going to store any message, whether that message is from user, system, or AI. And operator.add, this operator module. Operator.add simply means we want all the messages in the list. We don't want to delete the previous messages. Every time, whenever there is a new message, just append that message in our list and don't delete the previous messages. Just keep on adding, keep on appending those messages to the list. Okay. So in messages key, we are going to have a list of all the messages. In user ID, we will store the unique ID of the user who is interacting with the application. And then user query key will hold the actual user's query. Means, let's suppose user asked plan a 7-day trip to Dubai. So this user's query will be stored in this user query key. And then we have this trip constraints. And guys, see this trip constraint key, selected agent, and supervisor reasoning. These keys are new, and in our last two videos, part 1 and part 2, we haven't used these keys. Now let me explain you what are these keys. So what kind of data this trip constraint key will store? It will store a dictionary. Means, if user asked plan a trip to Dubai, so one of the trip constraint will be destination, where destination will be a key, and the value of the destination will be Dubai. Okay, so we will discuss this part in detail in some time when I will explain you the coding part of supervisor agent. Now I'm just giving you a brief idea what these keys are storing. Then we have this selected agent key. So in this selected agent key, supervisor agent will store all the selected agents which it selected as per the user's query. So for example, if user's query is find the weather of Delhi, so supervisor agent will select only one agent, which will be a weather agent. So in this selected agent key, what will be the agent which is stored? This weather agent. And now let's suppose if user asked plan a 7 days trip to Dubai next week. Now, as per the user's query, supervisor agent will select the relevant agents. So the relevant agent can be a flight agent, hotel agent, itinerary agent, and budget agent. So those selected agents will be stored in this selected agents key. And then there is another key with the name of supervisor reasoning. And this will store the data in the form of string. So what this super reasoning will store? See, when supervisor agent will select the agents, for each agent, it will have one reason, means why supervisor agent selected that particular agent. So that reasoning part we will store in this supervisor reasoning key. Then we have this flight result, hotel result, weather result, budget result, and itinerary. So, guys, these are the keys which we studied in our last class also. So, this flight result is a key which will store the output of flight agent. Key will store the output of hotel agent. Weather result will store the output of weather agent. Budget results, this key is new, but from the name only we can understand that this will store the output of budget agent, which is a new agent. I've told you in the beginning of our today's class that this is a new agent, and the output of that agent will be stored in this budget results. And then we have itinerary agent. This itinerary key will store the output of that. And guys, see, after that, these three lines are new. These three lines are related to the feature human in the loop feature. So, approval request. I've told you that our travel AI application will start working. Every agent will do the work. Then we have itinerary agent. Itinerary agent will generate the draft of itinerary. And after that, that itinerary agent will ask the user if user liked that itinerary or if user needed any change in that itinerary. So the message which our AI application will show to the user when it will ask the user to see the draft in this approval request. Then human feedback. Human feedback simply means human will provide the feedback. That feedback will be stored in this. And approved boolean. See, over here the data type is boolean. Boolean simply means user will either approve it or it will not approve it. So answer will be yes or no, true or false. So for that kind of data, we need this data type. So that's why approved key will store yes or no if whether user approved the request or not. And then this final response, and this final agent is responsible to generate the final response. So the output of that final response agent will be stored in this final response. And then we have LLM calls. So this will tell you that how many times LLM is called in your application. So this is our travel state. Travel state is a shared memory. All the nodes of LangGraph will take input from this shared state, and after working, they will store their output in this state. Okay. So this file is also ready. Now let's go back to agents.py file. And now you understood what all these packages are. Now let's start writing the code of agents. But guys, before that, first let's load the LLM. Which LLM we want to load here? The LLM which we have mentioned in config.py file. So this LLM, first we need to load this LLM in agents.py file. So you can load it like this. See, in LLM variable, I'm just writing the name of the function where we have loaded the LLM. So after loading this LLM, now we will write two helper functions. So let me write the function first, then I'll explain you why we are using that function. So this is my first function. The function name is LLM text. And guys, see, this code you are already familiar with because we have used this code in both the parts, in part 1 in part 2 video. See, we are calling the LLM using llm.invoke. Then we are providing it a system prompt, and then we are providing it a user's message, and then LLM is generating a response, and response is getting stored in response variable. Then by writing response.content, we get the actual output from the LLM. So instead of writing this part again and again in every agent, I wrote this part in a function, and we will call this function wherever we want to call the LLM and we want the output from LLM. Okay, so this is our first helper function. Now let's write another helper function. So this is my second helper function. Okay, wait. See, the function name is JSON from LLM. So guys, as I've told you that the output from LLM, output from MCP servers, we mostly get the output in the form of JSON. So we need to get the exact data from that JSON. So for that, I have used this JSON from LLM function. So first, whatever the output we get from LLM. So means first we will use this function. This function will generate some output. That output we are showing over here. Then from that output, the output which we got from LLM, we are finding the position of first curly braces, and then we are finding the position of last curly braces. And whatever is written in between these two curly braces, that part we are storing in JSON text, and then we are just printing that output. So guys, this part and this part is just printing the output of the variables, and I wrote this so that you can see on screen what exactly you are getting after each step. So if you want to delete this part, you can delete it, this part you can delete, and this part you can delete, because this is just for printing purposes. And then we are loading that JSON. So we will use these two helper functions. Now let's create supervisor agent, because the first agent will be supervisor agent, and supervisor agent will decide as per the user's query what all agents are needed for a particular user request. So let's create that. So I have created one function with the name of supervisor agent, and that agent is using the state as an input. So what is this state? Remember this travel state? What is this travel state? This travel state is a shared memory which we have created in state.py. See this, right? So every key is responsible to hold some sort of output. So this user query key we have over here, whatever user will type, that is stored in user query key, which is a part of travel state. Okay. So Let's go back to agents.py file, and here. Now, the input to this agent is state. From that state, it is picking the value of user query key. Remember, user query key is used to save the query which user typed. Now, supervisor agent got the user query. Now, supervisor agent will use the LLM in order to select the agents as per the user's query. And for that, we will first write one prompt. So, guys, whenever we work with LLM, what we do? We first write one prompt, and in that prompt, we tell the LLM how to behave, right? So, we are going to write a prompt over here. So, let me write a prompt. So this is my prompt. See, in prompt variable, I'm writing a prompt. What is it? You are the supervisor of a real world multi agent travel planning system. Decide which specialist agent are needed for the user request. And then we are mentioning that these are the available agents. So, flight agent is available. You can use it when flight, airport, airline routes, or airfare related information is needed. Use hotel agent when you want to find out the hotel stays in neighborhoods. Use weather agent for climate season, these kind of things. Use budget agent when you want to perform this functionality, and use itinerary agent for preparing the itinerary. And then we are also mentioning that return only JSON with this schema. Means we are telling it to provide the output in this format only. You have to provide the output in JSON format and follow this schema. Means we are telling the LLM that first you will write the name of the agents which you have selected in selected agents. Then in trip constraints, create destination key, and in that you will store the name of the destination which user mentioned. Then mention origin, then mention duration, mention budget, mention travel style, and if there is a special preference, mention that. So this trip constraints, guys, remember when we created this travel state class in state.py file, over there we use this trip constraints, and I've told you that I will explain you about it when we will create the supervisor agent. So now, what kind of data it will store? This trip constraints, this kind of data. So under trip constraints, there will be one key with the name of destination, and from the user message, supervisor agent will fetch the name of the destination. Means LLM will fetch the destination from it, and it will store the name of that city or country over here. Then it will fetch the origin from there and write it over here. And if user mentioned the duration, then that duration will be stored in this duration key. And if there is a budget mentioned by user, that will be stored over here. Travel style will be stored over here. And if there is any preference which user mentioned, that will be stored over here. Okay, so we are telling the LLM to provide output in this format, and then we are also asking the LLM to provide reason, whatever steps it took, why it took it. And then we will also provide the user's query to it. So, why this query variable? Because in this query variable only, we are storing the user's query, which the supervisor agent will take from state. So, this is the prompt which we prepared for LLM in supervisor agent. Now, in a separate variable, let's use the LLM. Let's provide this prompt to the LLM. So see, in raw variable, I'm using LLM text function. Remember this function? We created this function over here. See, LLM text. This is the prompt. You route work to specialist agent, return strict JSON only, and the prompt which we have created, it is in prompt variable. See, in prompt variable, we are providing that prompt to it. And after this step, you can just print the output, and you can see what kind of output you get from LLM. And once you get the output from LLM, we used this function. And the task of this function is to load the data in a proper JSON format. I'm calling that JSON from LLM function. And the output of the LLM is the input to this function. And then we are just printing the output. And when you will print this output, this past variable output, you will see the same output, but their data type is different. So this past is basically storing the data as Python dictionary, but this raw variable is storing the output as a string. And if you want to see, you can write these two things: check the type of raw variable and check the type of past variable. You will see that the data type of string and the data type of past variable is Python dictionary. And we used this JSON from LLM function over here so that we can have the output of LLM as Python dictionary, because it is more manageable and it is more easy to use. So that's why we used it like this. And after this, write these two things. See, I created one variable with the name of selected. And from past, what is past? Past is the variable where we converted the output of LLM in a Python dictionary form. So from that past, I'm getting selected agents in a selected variable. What are these selected agents? Guys, scroll up and check the prompt. The prompt, this is the prompt. See, here where we mentioned what kind of output we want, how we want the output. Over there, we have mentioned selected agents, and I've told you that over here, LLM will write the name of agents which it's selected as per the user's query. So in selected agents key, what we are storing, we are storing the output of selected, and what we have in selected, the list of selected agents. So we are basically updating the state now. In this key of state, we are storing the output which we fetched from here. In trip constraints key, we are saving the trip constraints which we get from past variable. What is there in past variable? Remember the output from LLM, which is in JSON format, which is in Python dictionary format. So that is what we are storing in trip constraints. And in supervisor reasoning key, we are storing the reasoning from past. See, this trip constraints and reasoning, from where we are getting, if you'll see this part of our prompt over here, we have mentioned that we need the output in this schema, and we have trip constraints over here, we have reasoning over here, right? So we are fetching the data from these sections. And then messages, we are also updating this messages key. Remember guys, I've told you that after every step, whatever process is happening, all the messages we want to store in messages. So now once supervisor agent will finish its task, it will write this message in the messages key. What is the message? Supervisor created the agent plan. And after that, we are incrementing the LLM call, because over here we use the LLM, right? We use this function and this function is using LLM. So that's why we incremented the LLM call. So this is how you create supervisor agent. Our first feature, which I've told you we will add in our part 3 video, is added. We have added the supervisor agent. This supervisor agent will select the agents based on the user's query. Now let's write the code of other agents. Next agent is flight agents. We used this agent in our previous class also. We are creating one function with the name of flight agent, and the input to this flight agent is travel state only. And this agent is taking user's query from state and storing it in query variable. It is also taking the output of trip constraints from state, and it is storing in constraints. And then from all of those trip constraints, it only wants the destination. So it is storing it in destination. And after that, I'm just printing query, user's query and constraint on screen. And now we are using the MCP server. There is one function with the name of list airport and another function with the name of list airlines. We are providing the destination which user provided, and then we are storing in airports and airlines, and after that we are just printing the list of airports and printing the list of airlines. So once the flight agent gets the list of airports and airlines, it is using a LLM to write the output in a proper format. So for that we will create one prompt. So we are saying that create flight guidance for this trip, get the user query from query variable, which we have defined over here, query variable, and get the trip constraints from constraint variable. Then airport MCP data you can get from airports variable, the airports variable over here. So this list airport and list airlines, we are fetching these functions. See, list airport and list airline, these are the two functions which we have created in MCP client file, and these two functions are getting data from aviation stack MCP server. Again guys, if you don't know how this MCP client is working, then please check my part 2 video, then only you will understand these things. Now let's go back to our coding part. So MCP data it will get from here, and then we are mentioning include likely departure, arrival, airport, relevant airlines, estimated duration, fare range, peak season warning, and booking advice. Okay, so this is the prompt which we will provide to the LLM when we are using that LLM in a flight agent. So guys, this prompt is very important because your LLM behave in that way then. So we are calling the LLM text function. So what we have in this LLM text function, we are calling the LLM over there, right? Over here, we are mentioning you are a flight planning specialist and this is the prompt. This is the prompt and work accordingly. Then we are just printing the result of the LLM on the screen, and then here this function is returning this. See, in flight results, the result variable. This is the result of our flight agent. So flight result key, which is in a state, there we are updating the result. We are also updating the messages key, and LLM calls is also getting incremented because we are using the LLM. So flight result key is in a state. See, in a state we have flight result key. So flight agent will update the output over here, and LLM call is also getting incremented. See, this is the part. So our flight agent part is done. Now let's create the next agent. So our next agent is hotel agent. Again, the input to this agent is travel state, and it is also getting the user query from state, best hotels and areas to stay for. Based on the user query, it will fetch the city, and for that it will find the best hotels. And then we are just printing this query on the screen. And in this line, we are actually using the Teveli MCP server, remote MCP server, to perform the web search based on the user's query. And the result of this Teveli MCP server is getting stored in result variable. Now, in hotel result key, we are storing the results, and we are also updating the messages key. See, hotel result key, it will update this key and it will update the messages key. Okay, so this is our second agent. Now let's write the code for third agent. So this is our third agent. The name of this agent is weather agent. The input to this agent is travel state only. The task of weather agent is to give the current weather detail and perform weather forecasting, right? So it only needs a city name or a country name. So in constraints variable, it is fetching the trip constraints, all the trip constraints, and then in city variable, it is specifically fetching the name of the city or a country where user is traveling. Now it will perform two different functions on this city. It will first get the current weather and then it will perform the weather forecasting task. So first I'm just printing the city name on the screen. Then in these two lines, we are using the custom weather MCP server which we created. See, current weather is a function to get the current weather of the city. Forecast function is responsible to get the weather forecast detail of that city, and weather data is storing the current weather. forecast data is storing the weather forecasting. And we are just printing these two variables on the screen, weather data and forecast data. And in result variable, we are showing the output, and then we are just printing this result on a screen, and then this function is returning the result. We are updating the weather result key, which is in a state, with the result. Which result? This result. What we have in this result? Weather data and forecast data. Okay, and it is also updating the message key. It will write weather agent completed. Now we have written the code for 3 agents. Now let's write the code for next agent, which is a budget agent. And guys, this is a new agent. So in our last 2 videos, we haven't used this agent. So let's write the code for this function. See, budget agent function, the input to this function is travel state only. And to work with budget, what all things budget agent needed? It will need the output of flights, it will need the output of hotels, it will need the output of weather, it will need travel constraints. So based on all these parameters, it will work on the budget. So that's why it is getting the trip constraints from a state. It also getting the flight agent output from state. It is also fetching the output of hotel agent, and it is also fetching the output of weather agent. So these are the different things it needed, and it took it from a state. Then we are preparing a prompt, because we will use LLM for this task. So we will prepare the prompt for LLM so that LLM can work as a budget agent. So the prompt is analyze whether this trip plan is realistic for the user's budget. So then we are providing the user query to the LLM: trip constraints, flight result, hotel result, weather result. We are providing all these details to the LLM, and we are telling it that return a concise budget assessment with these parameters. First one is estimated cost categories, risk areas, money saving suggestions, whether the plan seems feasible. So this is our prompt. Now in result variable, we are calling the LLM function, where we are invoking the LLM and we are giving it a prompt: you are a practical travel budget analyst. And this prompt we are providing to it, and then the result of LLM will be stored in result variable, and then it is returning, the budget agent is returning this output. So budget result key, which is in a state, will be updated by the result which budget agent provided, means which LLM provided, which we are using in this budget agent function. Then messages key is updated with this, and LLM call is also incremented because we are using this function, and this function is using the LLM. So this is our budget agent. Now the next agent is itinerary agent. So this itinerary agent will create a itinerary, and then that itinerary will be shown to the user for human approval. Okay, so let's create the itinerary agent, and then I'll show you how human in the loop concept will work over here. See, itinerary agent. I created one function with the name of itinerary agent. Input to this agent is state only. Now to create itinerary agent need output of all the other agents. So that's what we are doing. It is getting trip constraints from state. It is also getting the output of hotel agent, output of weather agent, output of a budget agent. After that, we are preparing a prompt, because itinerary agent will use LLM only. Now we will tell the LLM how it should behave in this particular scenario. So we are saying create a clean draft travel itinerary. This is the user request. This is the trip constraint, flight agent's output, hotel agent output, weather agent output, and budget agent output. Make the output structured, practical, and ready for human review. Okay, so this is the prompt we are giving to the LLM, and we are calling the LLM over here. So this is a function which have LLM. So in result variable, LLM will provide the output. That result we are showing on screen. And after that, see, this is the part where human in the loop concept will work. See, approval request. This is another variable. In this, we are writing a message. This message will be shown to the user, okay, for approval. Please review this draft travel plan, and then whatever is there in result, that we are showing to the user. What is there in result? The draft itinerary, right? So this message will be shown to the user, and then this function is returning this. In itinerary, what is this itinerary? Itinerary is a key in state, travel state. See, itinerary. So over here, I've told you the draft which itinerary agent will create before human approval, that will be stored in it. So that is the part which we are doing over here. Itinerary key will have the draft itinerary. Then approval request will have this question, because this question agent will show to the user on screen. So that question we are storing in approval request key. Then this is the message. We are updating this message key with this message, and LLM calls is also incremented because we have used the LLM over here. So this is the itinerary agent. Now we will write one function, and that function will handle human in the loop logic. Okay, so let's write that function. See, the function name is human approval agent, and here I have one variable with the name of feedback, and I'm using interrupt feature over here. So guys, remember in the beginning when I was explaining you about all the modules over there, I've mentioned that we are using this interrupt module, and we are using it for the first time in our today's class. And this module, this feature we use when we want to stop the flow of LangGraph application, and we want to get the input from the user, input from the human. So this interrupt we are using over here. And interrupt simply means the execution of the application will stop, and this question will be shown to user. Do you approve this itinerary? And then in draft itinerary, from state, we are getting the value which is there in itinerary key. What is there in itinerary key? Remember, what is there in this itinerary key? The output of the itinerary agent, which is a draft itinerary, right? So this human approval agent will ask this question, and then it will show that itinerary to user. Approval request. Remember guys, what is there in this approval request? In state, see this approval request. This approval request have this question, please review this draft travel plan. So that question we are showing to user, we are showing the draft itinerary, and we are showing this message, do you approve this itinerary? Then we have expected response. Now see, here we have two conditions. Either user approve the request, or user doesn't approve. So if user approves, means if approved is true, then this draft will go to the final agent, and final agent will generate the itinerary. But if user said no, I need few modifications in it, then this part will work. See, human feedback, we will store the human feedback. In approved, whatever the user status is, true, false, that will go. In human feedback, whatever human provided the feedback, that message will go, and it will also update the messages key. So these three things this human approval agent will do. Then after this step, we will have a final agent which will prepare the final itinerary. If there is any request which user mentioned, then as per that request, final agent will prepare the itinerary. If user is okay with the current itinerary, then final agent will create the itinerary as per that. So now let's create the function for final agent. So this is the final response agent. The input to this function is state only. So guys, here these two things we are first printing on the screen, because these two keys are important for final response agent. Based on these two keys, final agent will create the itinerary. First one is approved. Approved means yes or no. Yes means user approved the itinerary, draft itinerary. No means user didn't approve the draft itinerary. And if user didn't approve the draft itinerary, then in human feedback key, we are storing the feedback which user shared. So this is the logic which we are implementing in this agent. If state approved means if user said yes, approved the draft itinerary, then this will be the prompt to the LLM. The human approved this draft itinerary, produce the final polished travel plan, get the draft itinerary from state. In state, we have a itinerary key, get the draft from there, get the budget results from state also. Okay. And if human didn't approved it, in else part we have the prompt when user didn't approve the itinerary. So in that case the prompt to the LM will be human didn't approve this draft, original user request is this, the itinerary prepared by itinerary agent is this is the feedback which human gave, and this is the budget result. Now on the basis of this condition, LLM will be used. If state approved is true, then this prompt will be given to LLM. Otherwise, this prompt will be given to LLM. Then whatever the result is stored in result variable. That result we are updating in final response key of state. See, in state, we have this final response key. And I've told you this final response key is storing the output of the final agent. So the final itinerary. So that we are updating. We are also updating the messages key with the output, and LLM call will be incremented because we have used the LLM. So these are the different agents which are needed. So agents.py file, what this file have? This file have the coding of agents. Now the next step is to compile the graph, because we are building the application in LangGraph, and in LangGraph we have nodes, and then we define the flow, how work should happen, right? So for that we will create a separate file. We will name it graph.py file, and in that file we will create the nodes, we will establish the connection between them, then we will compile the graph. So let's do that part. So create one file with the name of graph.py. So first we are importing all the modules. So you know what all these modules are, so I'm not explaining them. So these two modules are related to PostgreSQL database. Then to create a graph, you need these three things. End and start, both are nodes. Whenever you want to start the graph, you start with start node. Whenever you want to end the process, end the graph, you end it with end node. So these two nodes are provided by LangGraph only. So there is no need to write the code ourselves. And then there is a state graph. It is used whenever you want to build a graph. And then from agents file, agent.py file, the file which we created, from that agent file we are importing all the agents. So these are the name of all the agents. So budget agent, final response agent. So we have different Python function, and each Python function represents one agent. So we are importing all those Python functions from agents file. And then from config file, config.py, remember this config.py. So from there we are importing the database URL also. This database URL we are importing from there. And then from state we are importing travel state. So you know this is a state.py file, and from there we are importing this travel state. Now guys, before creating the graph, let's discuss few things. So I'm writing this, see, agent order. Now, what this agent order means? See, we are using supervisor agent, right? And the task of supervisor agent is to select the agents as per the user's query. Means, okay, let me open this image. See, this supervisor agent will select that as per the user's query, what all agents are needed for that particular request. So if user asked, I want to know the weather of Dubai, so supervisor agent will only select the weather agent, because as per the user's query, this is the relevant agent. But if user asks plan a 4-day trip to Dubai for next month, then to plan a trip, supervisor agent will use flight agent, hotel agent, budget agent, and itinerary agent. It will not use weather agent. It will not select weather agent. So selection of agents is done by supervisor agent. But once the agents selected, once the supervisor agent selected, okay, these four agents I want to use, who will define the flow of the agents? Means whether flight agent should work first, then hotel agent should work, then budget agent should work, then itinerary agent should work. This is the flow, right? Who will decide the order of the agents? The agents which are selected by the supervisor agent, in which order those agents will work? Who will decide that? Because that is not getting decided by the supervisor agent. Maybe supervisor agent first decided to run itinerary agent, and then hotel agent, and then budget agent, and then flight agent. Then this flow is not right, because itinerary agent should work after all the agents. So that's why we are using this agent order. Agent order simply means we have defined the flow manually ourselves, so that our application work in a sensible way. Let's suppose if selected agents are, let's say this is the first agent which is selected, and then it selected budget agent, and then third agent selected is this. Suppose if these are the three agents selected by supervisor agent, then flight agent should work first, then budget agent should work, then itinerary agent should work. So that's why we defined the flow over here. So this is the first thing. Then another thing is this route map. Route map means that if flight agent is selected, then run the flight agent function, flight agent node. If hotel agent is selected from the agent this order, then hotel agent function should work. If weather agent is selected from agent order, then weather agent should work. Okay. So these are the two things which are needed. Now we need some sort of code, some sort of function to execute the logic which I've explained to you. So for that, we are creating this function. See, the function name is selected agent, and this agent is also getting input from state. And in state, we have the list of selected agents key, right? Open state and see, we have the list of selected agents. And what do we have in this key? We have the list of selected agents, and those agents are selected by supervisor agent. So that list of selected agent we are storing in selected. Then we are arranging those agents as per this order. What it means? It means, let's say, if the list of selected agent which supervisor agent provided, in that agent the first name is this, and the second name is this, third name is this, fourth name is this, right? So we need to arrange the list of selected agents as per this agent order. So that's what we are doing. We are using a for loop, and we are arranging that list of agents in this order. So the task of this function is simply to arrange the agents as per the agent order. Which agents? The agents which are selected by selected agents. Now, once we have the agents as per this agent order, the next task is which one should be the first agent, means after the supervisor agent, which is the next agent. So we need to write one function to figure out the name of that agent. So for that, we will write this function, route from supervisor. What it means? The input to this function is state only. See, selected agent function. What we got from this selected agent? The list of agents which are arranged in this order. And here we are just saying that from this selected, means the list which is created by this function, just pick the agent which is at index 0. So always index starts from 0. So selected 0 simply means from this list, whatever is there on 0 index, pick that agent as a first agent after the supervisor agent. So that means, let's say this is the order, right? So flight agent is at index 0. So after supervisor agent, this agent will perform the work. So this is the first agent after the supervisor agent. Now the next question is, which agent will be the second agent, and then third agent, and then fourth agent, right? So for that also we will write one function. That function will help us figure out which agent should be the next agent after the first agent, and that first agent is getting selected by root from supervisor. So this is the function to know which is the next agent after the first agent, and the function name is root after agent. And inside it we are creating one more function, and that function is taking input from state only. See, first of all, from selected agents, this function, from this we are getting the list of agents as per the agent order, and we are storing it in this. Then we are getting the index of agent. Then what we are saying, see, current index plus 1. See, this is a simple logic. What we are doing, we are simply saying whatever is there on the index 0, just increment it, and whatever is there on the first index, that will become the next agent. See, after this step, now this is the next agent, right? So this is the agent which is at current index, and we want to know which will be the next agent. Then you will add 1 in it, and you will get the index of the next agent. So that is what we are running in this function, and this will always tell that after the current agent, which will be the next agent. So guys, these are the functions which we need. Now let's create the graph. So to create the graph, we are creating one function with the name of build graph, and to create a graph, we will use state graph, and we are providing the state to it, and graph dot add node. You can use add node to create the nodes. So we need node for all the agents. So see, one node for supervisor agent, flight agent. We need a node for hotel agent, weather agent, budget agent, itinerary, human approval agent, and final response agent. So we have all these nodes. All right. Now we need to create the connection between them, and we will create that connection using this function and using this function. This function will decide which will be the first agent after the supervisor agent, and this function will decide every time which will be the next agent. And all this task is happening as per the agent list which we are getting from this agent order. So see, this is how you create the connection between them. So graph dot add edge. Add edge means creating the direct connection, means from start node we are connecting with supervisor node, means start node is connected with the supervisor node. Supervisor node, what is there in supervisor node? Supervisor node have supervisor agent Python function. That means once start node is connected with the supervisor node, this Python function will work. And after that, see, we are using add conditional edge. Over here we used add edge, but here we are using add conditional edge because there is a condition. As per the condition we want to define the flow. So from supervisor agent, which will be the next agent, is decided by this function root from supervisor. See, root from supervisor. So I've told you that first agent after supervisor agent will be decided using this function. So that is what we have written over here. So from supervisor agent, using this function, we will know which is the next agent. And route map. Remember this route map over here. So what I've told you, that if flight agent is getting selected, then run this node. If this agent is selected, run this node. So that is what we have mentioned over here in route map. And after that, once the supervisor agent is connected with the next agent using this function, then which node should be the next one? So if the next node is flight agent, then using this function, we will get the next node. And if next node is hotel agent, Then using this function, we will know the next node. See, we don't know that after supervisor agent, when first agent is getting selected, that first agent can be flight agent, that first agent can be hotel agent, weather agent, budget agent. We don't know, right? Which agent is getting selected by this function. So, whatever the next agent is, if that next agent is flight agent, then this is how you will use the function, this route after agent function. So I've told you that this function is responsible to get all the agents one by one in a workflow after the first agent. So if next agent is hotel agent, then this is the function to get the next agent. If next agent is weather agent, then this is how you will get the next agent. So once the budget agent task is done, then we are not using conditional edge like this. After that, we are using add edge. Why? Because after that, we know that we need human approval. Then after human approval, we need final response. And after final response, the flow should end. So that is what we are doing. Once the itinerary agent created the itinerary, that itinerary will go to the human approval agent. Human approval agent will send its output to the final response agent, and then the final response agent will perform the task and it will produce the final response. And once the final itinerary is created, the flow should end. So, this is our workflow. And here we will also mention about the database. So if database URL means if database URL is provided, then connect with the database. Then we are setting up the checkpointer. Then we are compiling the graph with the checkpointer. Then this build graph function will compile the graph, and we are writing it in app variable. Means this app variable now have this build graph. Whenever we will use this app variable, that means this lang graph execution will happen. The app will work in this flow. So now we will create another file. Our app is ready, our coding part is ready. Now what we need, we want to run this app as a Streamlit app. So for that, we will create one more file. We will name it frontend.py, and in that we will write all the Streamlit designing part, and then finally we can run this application. So create frontend.py file. Now let's save the designing part in it. See, I've pasted the entire code over here. Because the only thing to notice that from graph import app. So from graph means from graph.py file, we are importing the app which we just built. So let's open graph.py file. The last line is app variable. In that app variable, we are writing it. We are building this graph. So this app we are importing in frontend.py file, and rest is just a Streamlit code. Now we can run it. So to run it, what will you do? You will write Streamlit run and then the file name. Now let's run it. Hit enter. See here we can write our request, and then it will create a plan and it will work. So let's say I wrote plan a 7-day Japan trip under 2 lakh rupees, and I prefer budget hotels and no overnight flights. Okay, so create draft plan. Okay, the supervisor plan. First, supervisor agent is working. Supervisor agent used these 4 agents. See, flight agent, hotel agent, itinerary agent, and budget agent. It is not selecting the weather agent. Why? Because this is the user's query, and in this query, there is no mention of weather. So the supervisor agent decided to select these 4 agents. Then the flight agent is working first. It is giving us the details of airports. You can read about it, booking advice, sample flight itinerary, budget breakdown also, right? Then it is using hotel agent, and it is providing us the details of hotels, and the it provided us the budget details, estimated cost categories, and then risk areas, and then it is providing us money saving suggestions also, and then feasibility of plan it is showing us. Then this is the draft itinerary. Guys, remember I've told you that itinerary agent will provide the draft itinerary. So this is the draft itinerary. And after that, it is asking for human approval. Remember, after the itinerary agent create the draft itinerary, it will ask the human if human liked this itinerary, and if human said yes and submit approval, then this itinerary will be the input to the final response agent, and it will generate the response. And if user said no, revise it, then user can write the whatever feedback user wants to give and then submit the approval. So I'm clicking on yes and click on submit approval. Then it is creating the final response. See, this is the final travel plan, sample flight itinerary, accommodation options, and then budget breakdown, then money saving suggestions, daily itinerary, the day wise. So this is how it will provide you the itinerary. See, till now we have used supervisor agent, we have used a human in the loop, but guardrail part is still pending. Now let's add the guardrail part, and we will see the output again. So guys, for today's tutorial, what I will do, I will add the guardrail on the input which user is providing. So what we want, see, when user will type the input, we will use guardrail to check if that input is valid, reliable, or safe. So if that request is safe and if that request is relevant as per our application, then only that request will be given to the supervisor agent. Otherwise, our AI application will block that request over there only. So we will implement this part, and you just need to do modifications in the supervisor agent Python function. So let's open that file. Open agents.py, because in agents.py only we wrote all the agents. So let's go at the top, and here, see, here is the supervisor agent. I'm just commenting this function, and I will write another supervisor agent function with guardrails. So let me just paste that function over here. See, I'm pasting the function here. See, function name supervisor agent, input is travel state only, and from the state we are getting the user's query. Now, input guardrail. I'm writing a prompt for guardrail. So what we are writing, determine whether the following request is valid travel planning request. And this is a guardrail prompt. See, guardrail prompt simply means we will give this prompt to LLM, and this prompt will tell the LLM to behave as a guardrail. Okay. So the prompt is determine whether the following request is a valid travel planning request, and return only JSON in this format. Allowed true means if that request is valid. So allowed true. And then we are providing this prompt to the LLM, and we have a LLM function. This function invokes the LLM. See, you are an input validation guardrail, return strict JSON only, and we provided the prompt which we created, this prompt to it. And then I'm just showing that output on the screen, and then whatever the output which LLM provided, we are converting that output in a Python dictionary form, because that way we can access the output easily and in a more manageable way. So that's why we use this JSON from LLM function. See, we have this function over here. The task of this function is to fetch all the data which is between the curly braces. Here we have mentioned the condition. If allowed false, then just write request rejected by input guardrail. So what will happen over here? So basically your LLM will see whatever message user typed, whether that message is related to travel. If that message is related to travel, then that message will go to the supervisor agent for further work. Otherwise, over here only, this request will be blocked. and it will return this. See, in selected agent there is nothing, trip constraints will be blank, supervisor reasoning reason, it will provide the reason, final response it will show, and it will show this message that guardrail blocked your request, and it will mention the reason. Okay, now let's test this app again with some different message. So I wrote what is generative AI, and just click over here. Now, this is not a travel related request, so it will block the request. Let's see if it works properly. See, supervisor agent. The request is not related to travel planning. So that's why it didn't selected any agent, and all the agent's output is blank. So this is how you can use the concept of guardrail, and the link of this code is given in description section. You can get this code from there. And guys, if my tutorials are helpful, then please like my videos, and if you have suggestions, then you can share them in comment section. Thank you for watching.